Hello, my name is Maya Netto, and I'm from Grace M. Davis High School.
My name is Audrey Pettingill, and I'm from Wilsey Wood.
And for the CNSI Nanoscale Microscopy Summer Institute, we will be demonstrating how microbiomes affect the health of living organisms. In this presentation, we are going to show you how microbiomes affect the health of living organisms, and our proposition is to treat bacterial issues in microbiomes by allowing bacteriophages to inject DNA and RNA into infected cells in a process called phage therapy.
So by now you guys probably already know what microbiomes are, but microbes are like shown in this picture, and they're basically just little microorganisms that cause disease and fermentation, and they're what make up microbiomes.
I will be showing you how intestinal microbiomes play a huge role in human health, with several factors such as digesting fiber, brain health, and immune system control.
And I decided to go more into skin, and so I'm going to be focusing more on acne, which is a disease of the pores. Basically, it just is your glands, your pores, basically up there, have sebaceous glands, and they produce sebum, which is an oil. And sometimes the sebum can produce too much, and then it causes bacteria to get trapped and produces acne. So,
microbiomes dictate such a wide variety of medical ailments. So if we can harness the power and figure out how to manipulate them, this would result in an array of benefits to society, which would mainly be in bacterial infections and skin diseases.
And one of the most important or just really big benefits for acne is Accutane is a really harsh medicine that you have to take with acne, and so phage therapy wouldn't be as harsh, basically. So then if you want to go to the pictures. So bacteriophages are shown on the very bottom and over here as well. They're also known as phages, and they are viruses that infect bacteria. They have, in the head part, they contain genetic material, and then they have pins and teeth that they use to cling on to prokaryotic cells, which are up there, basically bacteria, and then they inject their DNA. And using phage therapy, scientists go in and either manipulate the genetic material or create a synthetic genetic material, and inject it into bacteria that is harmful, and then the phages go in and their DNA and RNA take over and then make proteins, and then basically just break the cell wall and infect other cells.
We are proposing to use bacteriophages as treatment for several bacterial diseases, and the two main advancements we will be focusing on are dermatologic and bacterial ailments. To go about these issues, current research shows that we would try to eliminate the bacterial disease or pathogenesis determinants vectors for bacteria, and by using fluorescent microscopy, one could analyze unhealthy cells and use that information to determine how to construct the necessary bacteriophage needed to treat this particular issue. So in fluorescent microscopy, we could use quantum dots in the phage to show the genetic material and how it would affect the cell we are addressing. If harnessed, the bacteriophages could be applied to medical fields and treat infected cells with healthy RNA and DNA. We could also reverse this process by isolating R-type fluorescence, which could potentially be used as an antibacterial agent and treat things such as Pseudomonas aeruginosa.
So even though phage therapy has less side effects than antibiotics, there are still a few issues with the treatment. One of them is that the phages can possibly kill the bacteria too fast. So that would produce too many endotoxins and make the patient sick. Another is it's really expensive. So based on the phage therapy center in Georgia, it costs about $2,500 for outpatient care and then $20,000 for inpatient treatment. not including travel cost, and also if the facility doesn't have your specific phage, it is like extra cost for creating a specific phage for you. Phage therapy also can become resistant, just like antibiotics, and it also, the FDA has not really set up a system for phage therapy, so there's not as much testing done in the US than outside.
Although using these bacteriophages in targeting human health isn't heavily researched at the moment, scientists have gathered information as to the positive and negative effects that may occur to cells and microbiomes when using phages. This information has the potential to lead to a plethora of medical advancements that involve bacteria. In addition to this, new and innovative microscopes are becoming more prevalent. So with this acceleration in nanotechnology and microscopy, it's becoming easier to analyze microorganisms and figure out how they fit together in their collection of genomes.
Yeah. So, any questions?
So why do you think phage therapy is more efficient than antibiotics?
So phage therapy, we can like specifically target kind of more than antibiotics. So we're able to like, I don't know, do you want to go more in depth? Like,
So with phage therapy, we're able to customize it to the individual microorganisms in each person. So while antibiotics might not work for everyone, or it may be ineffective to some people, if we customize individual phages for each person, we have a much higher chance of treating the disorder or disease we're working with. Yes?
Since it's like very costly, how would you administer the treatment?
So like how would you take the treatment? There are different like ways kind of, and that's why the FDA doesn't have any systems. Some people take like a concoction, and so it's like almost like a little shot. Others would like, you physically would get a shot, and then there are other like pill forms. So it's just different forms, but there's not a real specific way yet. So it's just kind of like Wild West out there, whatever you want to do.
And part of the fact that it's so costly is because there hasn't been much research in applying phages to the medical field. So if we were able to figure out more how microbiomes react to phages, then we could lower costs and figure out how to revolutionize this technology.
So I was just kind of like worried. So previously you guys said that you said that acne is a disease, and you said that you gotta like take some whatever medicine to like.
Yeah.
But if I have like a pimple, I just pop it. Am I
Yeah,
doing
well,
it?
so it can be used for like cystic acne, where it's like, can you pull up the picture maybe? It's on this slide 5. Yeah. So on the severe, it's like cystic acne. You can't just like pop a cyst. So that would kind of be used in that text for like really severe acne.
That's your relief.
Yeah.
So on that topic, you mentioned Accutane. Are you familiar with some of the other treatments for acne?
Yeah.
What are some of them? Some of those common ones?
Like over-the-counter medicines and
Yeah.
stuff, and like, yeah.
Antibiotics, though, right? Are often
Yeah.
prescribed. It's just
Yeah.
in the severe case. Right? So what are the big advantages of the phage over antibiotics in that case? And in that case, how do you likely think you would deliver the phage?
Yeah, so
Like we stated earlier, with antibiotics, they don't always work for people because microbiomes are unique in every body. So if we're able to customize phages to people and analyze with fluorescent microscopy how it would affect each individual person's microbiomes, then there's a much higher chance of treating it if like antibiotics don't work for certain people.
So you're saying that antibiotics are less effective?
It depends on the person. They're less customizable to whoever's using them. So if they're not effective on someone, they have a much higher chance using a phage to figure out what's wrong and help treat that.
Yeah.
But how are they effective in terms of eliminating bacteria? Antibiotics.
Antibiotics eliminate bacteria or phages?
Antibiotics.
Do you want to take this one?
Where are most of the microbiome in the body?
In
gut.
the intestinal region?
In the gut, right? So what happens when you take an antibiotic? It's going to kill all of the bacteria in your entire body,
Yeah.
right? Whereas the phages, part of the big advantage is that they can target the specific bacteria and leave the rest of them alone, right? And in the case of skincare, you also be able to apply it in a way the gut never feels any effect.
Yeah.
So even the phage in the gut might be perfect, or even the bacteria targeted by that phage in the gut where they're not causing a problem might be perfectly safe. So it's good to think about what the comparative advantages and disadvantages of the two ways of killing bacteria is. Right? One's like a nuclear bomb. You've eliminated everything, right? It's like poison. And the other case, it's a selective targeted treatment, right? So they'll have different side effect profiles.
Do you have any idea of how long the phage will survive in the body once it is administered? Have you read anything about it?
Not really, but do you think longer than antibiotics?
I think,
Yeah.
well, no, probably with phage, they're pinpointing the certain problem. So as soon as they treat the cells, it shouldn't be a problem in how long they last in the body because they're already,
Inject their
Yeah.
like, DNA and stuff. So
Well, the point is it's got to get to the cells, right?
yeah.
So there's always this discussion of what the circulation time of any treatment in your body is. Is it going to make its way to where it needs to go before your liver and kidneys get rid of it? I think that the efficiency of phage, which is, I mean, to Michael's point, it's specificity and efficiency. Right? So it only goes to certain cells, and when it gets there, it is incredibly efficient. Like we learned about on Monday from Professor Miller's talk, and you're talking like they are killing machines.